Hi, my name is John Young. I'm a senior 3D artist here at Wise Engineering. In this video, I'm going to show you how to convert game models to create 3D printable mixed reality props. This tutorial assumes you have some basic 3D modeling and 3D printing knowledge and covers some more advanced topics. First, we have to determine the model we have to start with. In this case, the low poly game model is already created and we just want to make it 3D printable. Here it is imported into 3ds Max 2021. This 3D model is of a gas leak detector called a JCAD. The challenge here is that game models typically have a lot of the details faked in the textures, and this is for performance optimization reasons. These game models have to work in a real-time game engine, so they have to be, a lot of these details are faked in things like the texture map, but 3D model performance optimization is not important for 3D printing. So if we're starting from a game model and we don't have access to a medium or high poly detailed model from which the game mesh was derived from, we want to model this detail back in. The goal is to ensure the prop has the necessary tactile feedback when it's being physically handled. And here's what I mean by the details being faked in the texture. If I take a closer look at this model, you can see if I turn on my wireframe preview and select it, you can see some of these details like the buttons, certain aspects like the screen here, this orange light, and this label on the back. These are all textured on details. So if I remove these textures, you can kind of see what the actual geometry looks like. And the actual geometry is what's going to get 3D printed. You know, obviously those buttons and things like that. So we want to, for certain things like the buttons on the front, if we want to run our finger across the surface, we need to have that detail modeled in so that there's a physical representation of that. So first thing we have to do is set up our scene file units to ensure it correlates with our 3D printing slicing software. So to remain in the proper scale between 3ds Max and whatever slicing software we use, we have to change our unit system, our system units to millimeters. And we do that by coming over to Customize, and then Unit Setup, and then you have this System Unit Setup. Click that, and then just change this system unit scale. 1 unit equals to 1 millimeter. You can choose that from this list here. And then you can use whatever your display unit scale, what you prefer. I typically will work in decimal inches or millimeters. So we'll leave that way. Next, we need to verify the scale of our object. A quick Google search of a JCAD led me to find its real-world dimensions are roughly 7 by 4 by 1.5 inches. So I will use the measuring tool to verify the model's dimensions and scale the model appropriately. Ideally, the game model would have been modeled at the correct scale, but we can double check that and fix it at this stage so we know the game model and printed prop will be 1-to-1 scale to each other. So to find the measuring tool, I'm going to select the Utilities tab here, a little wrench, and I'm going to click on Measure, and then I'll select my object, and then it'll give me the rough dimensions. So it's about 4 inches by 1.5 by almost 7. So this is roughly the same measurements as what I was finding. So this 3D model has been modeled to the appropriate scale, and that's what I want to see. So this looks good. Okay, so now we can start reintroducing detail back into the model. One thing I find helpful is switching the viewport shading mode to facets. This will remove any smoothing post-process effect that the 3ds Max viewport adds on top of the 3D models, and it'll give us exactly what the surface of our 3D printed object will look like. And you can find that here if you click on where it would typically be default shading or edge faces. You have this facets option. So what that does, and I'll just zoom in a little bit. So now you can actually see the geometry of your 3D model and how it will appear when it's 3D printed. So if I'm going to turn off these edged faces. So if this cap is supposed to be smooth, because of the poly count of it, it'll actually have this kind of faceted look, and you'll feel this with your fingers. things that might be smooth will have kind of this edging to it. So I'm going to go through some of those details that are missing, like the buttons on the front. If something like this cap needs to be smooth, at this stage is when I'd go through and start reintroducing that detail, so it feels the the tactile feedback is appropriate to what you're trying to make here or recreate. So here we go. I'll turn on the texture, and then I'm going to build. I'll just start simple using these are just standard 3D modeling tools that I'm using in 3ds Max. And I'm just going to say that I don't know the exact height, but I'm going to eyeball it. So maybe this would be something like that. And then I'll switch this to a editable poly. And then I'll do my normal kind of modeling here. And then I could do the same for this circular button. So we'll start with something like a cylinder, because that's the shape of it. And we'll give it more sides. Scale it a little. And then I'll convert this to an editable poly. Grab the face, and I'm going to shrink the face. And I think it's a little too far inside, so I'm just going to pull this out as well. There we go. So there you go. And I'll go through and do this for many of these other details, like this light there. I know that is actually extruded out. I don't think the label needs something, although I could make a shape and that's protruding out of the back. So when you run your fingers over the back, you feel like there's a label there in the 3D print. But definitely these buttons, I'll do that light. And yeah, so I'll get started on those. So let's look at this light over here, for example. I will, so I selected the edit poly and I just grabbed it as an element because I know it's a separate object. And if I pull it up, I can see the bottom of it is this open face. And there's going to be issues printing this. So I need to cap this bottom. And I know a lot of these pieces, I can tell the screws, because these are models for a game. You don't necessarily have to make these back faces, because if it's not seen, it doesn't need to be there. The top cap as well. This whole front panel is all open here. So I'm gonna have to cap and bridge any of these. So let's turn off the texture because it's getting confusing seeing it there. So just for example, how I would approach this this piece here. So I'm going to hide. I'm actually going to detach this under my edit poly, edit geometry, detach. I'll just detach it to its own. Oops, I didn't do it right. There we go. And I'll isolate the selection so I don't have to hide everything. And so I can use my border and select border. I could try to cap this. This probably will work. Yeah, there we go. So now I've made this watertight. So there's a top and a bottom face. And then I have to do this for basically everything, all those pieces that are intersecting. So I'm going to end selection, end isolation. And I'll select the cap now. I'll do the same thing to that. You can see that this is made up of different objects. So we even have these little like kind of support beam pillars. So I'd have to do that for each of these, this part, but we'll just kind of do this shape for now. So I'll detach this, select it, isolate, select the border, and I can use cap. I can also, use edge selection and bridge between them. There we go. So now we have that cap there. And then maybe the last one I'll show you is kind of this front screen. I could do, I could hide unselected. It's really however how you work best or quickest. I could hide just the other unselected polys, make my adjustments rather than detaching. And cap. And then I'll go and hide all. So once I've gone through and made sure everything is watertight, I want to introduce some of that smoothing back into things like the cap and some of these other parts. So the way I do this typically is I'll add a turbo smooth modifier. So for this cap, for example, I'll add turbo smooth. And you can see it really crunches the detail. It doesn't have any control edges, so things that should be kind of sharp and crisp, these edges, they kind of get crunched. It's not doing what I want it to. A quick way to fix this, of course, you can add your control edges. I could add a loop of edges along so it doesn't smooth across that surface so dramatically. A quick way I like doing this is I'll separate my smoothing by smoothing groups. Sometimes it's set up well. You can see that these different smoothing groups, it does not smooth across them. But other times it's not set up correctly, so I could come in and try to, I can do a clear all, I can do an auto smooth, and let's see if that is closer. It's a little closer. It fixed some of the areas in here because it could just tell there's a change in the angle, and it'll set up the smoothing groups according to the settings I have there. But let's see this. So this pinching here is not ideal. It's not what I want. And I might want this to be kind of sharp as well. So I'll come in, select my polys. I'll select that loop there, and I'll adjust the smoothing to a different smoothing group. And I can see how this is affecting it in real time. And then we can do the same for this loop, cross. Okay, and let's take a look without the wireframe, and I'll adjust the iteration a bit. Okay, and I think that works. Okay, so I've gone through and I've re-added in all the detail I wanted to. I smoothed out the entire object using smoothing groups, and some areas I used control edges. And now I am in facets, so I can see that when I print this is exactly how the model is going to look and feel. So you can see that everything's going to be nice and smooth. You can kind of see some faceting here, but at the scale this object is, it's not going to be terribly noticeable. And if I really wanted to, I could just increase the iterations of the turbo smooth. So at this stage, I have to think about how this object will fit together after it's printed and engineer any points of separation at this stage. So we need to determine a few things. Does my model have significant overhangs that will generate a lot of support material? Because this could have a significant effect on print time and the amount of material used. Am I going to paint it? Should I print certain parts in different colored plastic? Splitting up a model can help with painting parts. Do I need to integrate real hardware into this print? You might have to create something like inner geometry to like a compartment to house those components. So depending on your answers to these questions, will determine how and where to cut up your model. In this case, since we're going to print this object in one plastic, I don't really have to worry about separating any elements because the shape of it is primarily a box, so support material generated is going to be pretty minimal. So I do want to think about some of these added details, and just for example, this button that I added. So right now it is a separate piece of geometry, and you can see I can pull it out. It does have its back face created, so it is considered watertight, but we need to, I can't have any of these elements floating on the model. This is going to cause issues in the slicer as well. So what I like to do is I'll Boolean all of these objects to create one solid contiguous mesh. So to Boolean, first thing, always make sure you save this model in particular. After I've gone through and turbo smoothed everything and created all these control edges and used smoothing groups, it's actually quite heavy. So sometimes your system can drag when you try to Boolean two different objects together. Sometimes it can crash. So just to be safe, I always go and save. I'll go to File and just save a quick copy. Okay, so I'll grab the object, and then I'm going to go to the Create tab, Compound Objects, and then I will select a Boolean. Okay, now this converted it to a Boolean object, and then I want to merge, I'm going to union this button to the rest of the object. So I'm going to add operand, and then select that button. Okay, and it added it there. So now you can see that this button has actually been merged to the, unioned to the face of this object. So if I go along to the back here, there's nothing protruding inside anymore, and it's attached. So now I can, if I want to collapse this, I can just right click. So I can right click and convert to editable poly. There we go. So now I have a collapsed mesh. All these buttons are all attached, and they're all Boolean together. So this is going to make things nice and clean when I go and send this to the slicing software. Okay, so I'm going to export this model, and I'm going to choose a STL file format. This works well with 3D printing slicing software. So we have to first select the object, and then go to File, and then Export and Export. And this will give you the option to select the STL file format. So when I do that, and I'll just name this as a JCAD print, and I'll save. And then there's this checkbox here that says selected only, and I want to make sure that's checked on. So whatever I have currently selected gets exported, and then we'll say OK. And then I'm going to open this up in my slicing software. Here I am now in Ideamaker. Ideamaker is Raise3D's proprietary slicing software. They're just a brand of 3D printers. If you have your own 3D printer, they might have their own slicing software that you would use. So from here, I'm going to import the model that I exported, the STL file. And there it is, and then I'll import. And you can see here, this is a pretty large print volume for the printer. It's called a Raise3D N2 Pro Plus, and we have a 12 by 12 inch build volume that is 24 inches tall. So my object, fits just fine within that build volume, and I can just double check the bounding box size here in millimeters. And then I could just plug these numbers into Google and just verify that this is, the right scale according to the scale in 3ds Max. And I can tell just by looking at this that it is. And this would be a good point to bring up, that if my object was too big that it didn't fit inside of this build volume, that would be another reason that I would have to break up that model into separate pieces, so I could print them separately and then reassemble them, if I needed more room. Okay, so just another quick note. This I am getting some errors, some non-manifold edges, and some issues with orientation faces. You can run a repair to try to fix this. Basically, there must have just been a couple of things that I missed. But it typically, I mean, I went through all the important stuff. All of these kind of, everything has back faces. There just might be some unwelded vertices in certain areas after the Boolean. So that's probably what this all means. But why don't we, I'll just run a repair operation. If you're using a different slicing software, generally they have something like this. So let's just give it a shot. And then I'm going to apply auto repair. Okay, and so it fixed the orientation faces, but the model still has non-manifold edges, and it's still giving me kind of an error warning here. But just based on my past experience, if I'm careful about everything that has back faces in the 3D modeling software, I can just kind of ignore this, and it usually slices just fine. So I'll just kind of briefly show you that process. It's very streamlined in Ideamaker. I'll just start slicing. I have a variety of templates that I use, and I'll just use this standard one. And you can, obviously you can adjust settings. You could add things like platform additions. In this case, I'm adding a raft. You could generate the support and adjust the overhang angle that it generates at. So right now I have it set to all, and then anything over 65-degree angle gets support added. And so I'll save that, and then I'll just slice, and we'll see what that gives me. Okay, so we got a estimated print result. It'll take about 11 hours, 140 grams worth of material. And this is assuming it is, I believe, a $30 spool of filament. So that's about, $3.23 worth of material. And we can give this a preview. I could just look at the support material that has been added. So everything red is, you can see the solid fill, and then the blue here is the support material. And like I said, because this is just mostly a box, I wasn't concerned about really significant overhangs. If I was, and I didn't want any supports on the front side of this, maybe I could angle it kind of back or something like that. But it works out that the support would be under the object here, because I don't, that's not really an area of the model that people would be looking and feeling all that much. So, and I can kind of slide the layers here and just take a look and make sure that all the parts that I believe are Boolean properly, are, and it does look like everything is. And I would be able to tell if I saw, like, for example, if I hadn't Boolean this button here, it might just be floating. There might be a line here, a solid fill, or that is just kind of floating, and that piece would easily break off. But you can tell that it's actually changes the exterior, and then the infill takes up the rest of the model. So this all looks good. I think this is going to be a successful print. So our object is sliced, and now we can upload it to the printer. Brace 3D has a function to just wirelessly send files over your internet connection, or we can save this to a flash drive and then put it in the printer. Thank you for watching. I hope you found this tutorial on how to take a 3D game model and make it a 3D printable prop useful. If you'd like to see more like this in the future, please leave a comment, like and subscribe to this video, and we'll see you around. Thanks a lot.